And we just take some values for which we have the exact value for the cosine. So we let the theta equal to 0 degrees. Then we know cosine 0 degrees is equal to 1. 2 times 1 got a 2. So in this case, r is equal to 2. And you let the theta equal to 30 degrees. So cosine 30 degrees is equal to root of 3 over 2. And 2 times root of 3 over 2, you get root of 3. And 45 degrees, then you have the root of 2 over 2 times 2, you get root of 2. Then 60 degrees, 1 half. 1 half times 2, you get 1. Then 90 degrees, you have the 0 for cosine. So 2 times 0, you have the 0. And then 120 degrees, we know the reference angle for the 120 degrees is 60 degrees, right? And in the quadrant 2, cosine is negative. So this is equal to, okay, cosine of 120 degrees is equal to negative cosine 60 degrees. And then this is equal to negative 1 half. So negative 1 half times 2, you get negative 1. And then 135 degrees. So we know cosine of the 135 degrees is equal to negative cosine 45 degrees. So that is a negative root of 2 over 2. Then you multiply this value by 2, you get negative root of 2. Then 150 degrees, we know this is equal to negative cosine 30 degrees. So you get negative root of 3. And the last one, 180 degrees, then you get negative 2. So in this way, we can form a bunch of the polar coordinates. We have the 0 degree and then 2. Hold on. We need to put the r first, right? So we have the 2 and the 0 degrees, and then we have the root of 3 and the 30 degrees, then root of 2, 45 degrees, and then 160 degrees, and then 0, 90 degrees, and then negative 1, 120 degrees, and negative root of 2, 135 degrees, and negative 3, 150 degrees, and another one, let me put here, negative 2, and 180 degrees. So now we can force plot all these points, and we can use some smooth curves to connect them to get the graph of this polar equation. So let's move to the next page. And first we get the pole and the polar axis. So we begin with the first point, 2 and 0 degrees. So suppose this is a 1 and this is a 2. So this guy, this is the 2 and 0 degrees. Right, let me use the color. So this is my first point. And then we have the second polar coordinates, root of 3 and 30 degrees. So 30 degrees, it's here, okay, and root of 3 is about here. So this the root of 3 and 30 degrees. And then we have the root of 2, 45 degrees. So root of 2, 45 degrees. And let's first draw this angle 45 degrees, and then root of 2, so it's about here. And then 60 degrees, and it's equal to 1, so 1 is about here. Actually, mine is not so accurate. Anyway, so here, maybe let's get here. So you just plot all those points on this rectangular plane, and then you will see, finally, you can get such a graph. And this graph is like this. Okay, not so accurate. It's a circle. So this guy, the graph of the r equal to 2 times cosine theta is a circle. Now, let's see how we convert this polar equation to a rectangular equation, and use the knowledge we have learned about the circle to prove the graph of this polar equation is really a circle. So, to do this conversion, we first multiply both sides by r. Then we get r squared equal to 2 times r times cosine theta. Because we know x is equal to r times cosine theta, right? We know the r squared is equal to x squared plus y squared. And x is equal to r times cosine theta. So now we can replace r squared by x squared plus y squared. So left side is equal to x squared plus y squared. And here, this part, r times cosine theta, we just replace it by x. Now let's put this in the standard form. Let's move this 2x to the left side. Then we have the x squared minus 2x. And we try to complete the square. So we add 1 to the left side and also to this right hand side. Right? So actually this is 1 plus 0. When we move the 2x to the left side, we have the 0 on the right side. And then we complete square, so we have the x minus 1 square plus y square equal to 1. So now you can see this one is just equation of the circle with the center equal to 1 and 0. So here it is 1 and 0. And the radius r is equal to 1. So in this way, we convert this polar equation into a rectangular equation, and then prove the graph of this polar equation is really a circle. Any question?